So let us look at the case of a 2D system. And so we said that we have a linear shift invariant system. Oh, by the way, did I say that this HMN is called actually a point spread function? I have to say that. So the impulse response, the HMN, right? This has a name. This is called point spread function. So what that actually means is that it actually indicates how a point light source will get spread out, right? If it is not in focus, it's called a point spread function, and there are various models for it. Okay, for at least for the optical blur case, there are models. We'll look at a few of them. So this is called a PSF in short. Okay, so you have a point spread function of some 2D system, right, lens based, and let's say that you input, what am I using, F and G, whatever. So let's say this is FMN, this is HMN, and out comes GMN. And G is F convolution. I'll indicate it as by 2 stars just to indicate that it's actually a 2D convolution, F H. Okay, so point spread function, because it tells how a point light source is spread by the lens, spread out by the imaging system. In this case, of course, a lens based imaging system. Okay, so it's called a point spread function. Now let's kind of go to this figure now. Okay, again, we'll take a very simple example just to make things easy to write here. So what we'll do is we'll assume that H is so these both exist from, so let's say FMN and HMN are non-zero. Let HMN and HMN be non-zero only for, let's say, m comma n less than or equal to 1. Rest of the places on the grid, they are 0. So what that means is that on the grid, on the grid, right, when we draw, so on the grid when we draw, right, so let's say that we have same thing will hold for both. Okay, I'll just draw one grid. So suppose I indicate by a cross, that means a value exists there. So let's say this is 0 cross 0 comma 0, and let's say this is let's use row comma column. So this will be 0 comma 1. You can use any this one notation. I'm just using some notation here. So this will be like 1 comma 0 then, and this will be 1 comma 1. Okay, so we are saying that HMN and FMN, they both exist like this, and everywhere else they are 0, just to illustrate, right, what we want to tell. You can then later on you can write your own code. You can take whatever size you want. It will just blow up. Even to write this, it will require a big matrix and so on. And then we will again go and implement a linear convolution via circular convolution. Implement linear. For the same reason, right, that I said yesterday, that linear convolution when implemented via circular convolution gives you the circulant kind of a structure for the system matrix, which has certain interesting properties. First of all, it is normal, therefore it is unitarily diagonalizable and so on. At least there is a structure, right, that you can see. Implement linear convolution via circular convolution. Okay, so then which means that we need to zero pad and cyclically repeat now, but this repetition should be on the grid. Earlier we did it on 1D, right, yesterday. That was a simple example. We could just repeat. Now this is also simple, but we have to be a little more careful. Now again the length will be So what we have, so it will be like 0 to 2 now, okay. So of the output, right. So we'll go like, so I'll put a 0 here, I'll put a 0 here. So dot means it's a 0, and then 0, 0, 0. So here is 0 comma 2, and this will be like 2 comma 0, right, and then this will be like 2 comma 1 and so on. And then this should now cyclically repeat on the grid. So it will be like saying that, I'll have this, okay, and then this, again. I have to repeat it cyclically, either this way or that way. Either way doesn't matter. Let me repeat it like this. And then either I can go this way or I can repeat this way, shouldn't matter. Only thing is the spacing is not very uniform, but that is alright. Okay, and then it sort of, right, it'll just go on and on and on. So this is like cyclically repeating the pattern. This is valid for both F and H, right? And we are now looking at a convolution of the form, right, G of m comma n. So we want to write, similar to the case that we did for 1D, where we saw some structure in the system matrix that relates the input and the output. Similarly, we want to see if there is a nice structure here, right? So GMN will be double sum. Let's say m prime n prime going from 0 to 2, and then let me take it as f here, because f we can write on the right hand side, okay. F of m prime comma n prime, then h of m minus m prime, n minus n prime, right. And let's write this down. So what is it? We have like g of m comma n is equal to, so what will it be like? F of 0 comma 0, h of m comma n plus f of 0 comma 1, h of m comma n minus 1, h of m comma n minus 2 plus f of, so 0, 0 comma 2, so 1 comma 0, h of m minus 1 comma n plus f of 1 comma 1, h of m minus 1 n minus 1 plus f of 1 comma, 1 comma 2, h of m minus 1 comma n minus 2. Then lastly, f of 2 comma 0, h of m minus 2 n plus 2 comma 1, m minus 2 comma n minus 1 plus f of 2 comma 2, h of m minus 2 n minus 2, right. So that will be now the idea is to be able to write this in this form now, okay. So this is called a lexicographical ordering, okay. What that means is, if you have a G which is now actually a matrix, so you take the first row, stack it up as a column, take the next row, stack it below as a column following that, and then you kind of create a 1D sort of a vector out of a 2D array. So that is called lexicographical ordering. So in this case, what it will mean is, we will write this G, we will lexicographically order it such that we have G00, G01, G02, G10, G11, G12, G20, G21, G22. Okay, you will understand the importance of all of this later. Why we write it in this form, and why it is convenient to write it in a lexicographical model. Because if you write it this way, right, then the way that you can go from a 1D to a sort of a 2D transform, it all becomes very easy. Okay, it makes it very convenient to actually write equations by simply borrowing from your 1D 1D ideas. Okay, I'm going to write this as some big matrix, right? Not so big. I think 9 entries we have to write here. So let's say we go up to this, and then here also we will lexicographically order. In the same way, of course, whatever, you can also take the first column, put that as a first column, take the second column, put it below, but whatever you do on the left, do the same thing on the right. So here FF, so one is like row lexicographical ordering, another is column lexicographical ordering. 0, 1, F0, 2, F1. Okay, and this all means that it is 0 padded. Okay, 0, 2 is 0. FF, what is this? 1, 1, FF 1, 2, then FF 2, 0, 2, 1, FF 2, 2. Okay, we want to be able to fill all these 9 rows now. We'll fill 3 rows, and then after that, right, we'll just assume that okay, you can actually fill it up, because we don't want to spend too much time. But just to give everybody here an idea about how this will work now. So now if you take G00, that means M is 0, N is 0. So F00 multiplies H00, correct? F0, so this will be H0 comma minus 1. So 0 comma minus 1 is this, so it is 0, no? So let's go here and let's, okay, I'll enter it in this itself. So okay, what is the next one? 0 comma minus 2. Okay, now can I say somebody tell what is 0 comma minus 2? 0 comma minus 2 is this one, right? Is this one, which is the same as 0 comma 1. Right? So let's go here, fill this up as H01. Okay, I'm going to write it like that. Then here F10. So what is multiplying F10? H minus 1. What is this? H minus 1, 0. And then what is the next one? So minus 1 comma minus 1. So if you can kind of see quickly, tell me what is minus 1 comma minus 1, that is also 0. And then what about the next one is minus 1 comma minus 2. So minus 1 is here, minus 2 is here, no? Minus 2 will be here. So that is also 0. Okay. Then let's come to F20. So here it is H minus 2 comma 0. So H minus 2, let me go down here, H minus 2 comma 0 is this one. This is the same as, this is the same as 1 comma 0. 1 comma 0, right? Same as 1 comma 0. Then 2, so we are here, so this is 2 comma, so 0, minus 2 comma minus 1. So minus 2 comma minus 1. So minus 2 minus 0, right? Minus 2 minus 1 will be here. We will land here. So okay, that's a 0. And then finally, not finally, finally, minus 2 comma minus 2. So minus 2 comma minus 2, bloop here, and then you go there, and that will be 1 comma 1. Right. So 1 comma 1. HF 1 comma 1. And now, I want you to tell me G 0 comma 1. What should I write here? First entry. Somebody tell me. Oh, you want to see that grid again? Okay. 0 comma, right? Okay. 0 comma 1. Then, yeah. H 0 comma 0. Then 0. Then. Okay, what do I write here? No, is it, what is it? H01? Are you sure? What comes here? This is, so you're looking at 0 comma 1 and you're looking at 1 comma 0. So it is 0 comma 1. So it will be minus 1 comma 1. So you look at what is H minus 1 comma 1. So H minus 1 is this and 1 is, so that's 0, no? Minus 1 comma 1 is 0, right? So be careful. Next. What next? 1 comma 1, no? So you have to write for 1 comma 1. So we have finished 4 entries, 1, 2, 3, 4 gone, 1 comma 1. So 1 comma 1 is sitting here. So that is, we are looking at 0. So minus 1 comma 0. So what is minus 1 comma 0? So minus 1 comma 0 is this guy. So it's 0. Okay, then next. Maybe you'll just make a guess that maybe that also ought to be 0. Don't make a guess. 2 comma, so this is what? Minus 1 comma minus 1, minus 1 comma minus 1, right? So what is that? 0. Okay. Then let's go to 2 comma 0. So this will be minus 2 comma 1. So minus 2 comma 1 is this one. That is 1 comma 1. Oh, what is it? Am I correct? Minus 2 comma 0. Oh no, sorry, 1 comma 0. No, minus 2 comma minus 1, no? It's not minus 2. Minus 2 comma 1, right? So, minus 2 comma 1 will mean we are here. That is 1 comma 1, right? You guys are following, right? 1 comma 1. Then 2 comma 1. So, which is here. So, where are we? So, minus 2 comma 0. So, minus 2 comma 0. So, minus 2 comma 0 is this guy, which is 1 comma 0. 1 0. Then 2 comma 2. So, that will be, where are we here? 0 comma 1. So, it will be minus 2 comma minus 1. So, minus 2 comma minus 1 is 0. Okay, third one. G0 to 0. Huh? Okay, then next 0 comma 2, no? So look at 0 comma 2. So 0 comma 2 is 0 comma 1 now. Yeah, it's 0 1, no? Why do you have to think so much? This one is the simplest, right? 0 comma 1 and then 0 comma 0. 0 comma 0, no? Third one. Then come to the next one. This is whatever we look at 0 comma 2, right? So it's minus 1 comma 2. So minus 1 comma 2 will be minus 1 is here and then 2 is 0. Correct? So 0. Then minus 1 comma minus 1 comma 1. Right? What happened? 0 comma 2, where are we? We are doing for 1 comma 1 now. Okay, we are doing for 1, we are doing for 1 comma 1, right? We have finished these 4, no? We are doing for 1 comma 1. So here and 0 comma 2, so it's minus 1 comma 1. Minus 1 comma 1. So minus 1 comma 1 is 0. So minus 1 is this one, 1 is this one, so that is 0. Okay. Then let's go to the next one, 1 comma 2. So it's like minus 1 comma 0, 0. Okay. Then 2 0. So we're looking at minus 2 comma 2. Where are we? So last one, right? If 2 comma 2. So this should be minus 2 comma 0. Okay. So minus 2 comma 0 go the correct way. So minus 2 is like 2 rows down, and minus 2 comma 0 is this guy. This is 1 0. Okay. And now, right, I'm going to fill up the rest and leave it to you to just to see, verify. Okay. So now, right, what we have is G lexicographically ordered, F lexicographically ordered, and now this is again in the form G is equal to Hx. So this is the form G is equal to Hx or Hf. Now, what kind of structure do you see here? So if I see here H11, is it repeating? No, it is not repeating, but something is going on. Correct, yeah. Very good, right? So what you have to do is you have to look at it like this. Now if you do a partitioning, if you do this partitioning, okay, that is why I said that if I directly wrote it, you will figure it out. Now see, okay, if I try to partition it like that, right, what do you observe now? You observe that each of these submatrices, right, is by itself a circlet. See H0 0 0, H01, then H01, H0 0 0, then 0, H01, H00. So 0 0 0, H1 0 0, H11, H11, right? So each one of these is actually circulant, but then it doesn't stop there. Each of these matrices themselves repeat circulantly. See, this guy appears here, this guy appears to the right, this guy appears to its right, then again this one comes back here, this one comes back there, and this one comes back there, right? So when you have a 2D system, right, and then when you write down this kind of a matrix vector relationship, you realize that you get a matrix that is actually, if you look at it, is it circulant? No, it is not. Correct. I mean, directly if you see, right, this row, is it repeating or not? It's not. But then it has some other structure. And such a structure is called, do you know what it is called? It's called doubly block circulant. So as far as H is concerned, right, it has what is called a doubly block circulant. Okay, because it is circulant blockwise, and then doubly because each block itself is circulant. Right, so that's why it has its name doubly block circulant. The block circulant will mean that all these matrices just come in a circulant way, but each one of them being circulant within itself, right, makes it kind of doubly block circulant. And all these has implications. Right? The nice thing about these things is either, right, we can just choose to just look at that summation and then walk away, say that anywhere, right, that will also give us the same result. But the other way to look at it is to actually look and see the structure that actually lies there, and which and as it should happen. And then it turns out that when you have something like this, to diagonalize this guy, just as you needed a 1D DFT, a DFT matrix to that we haven't talked about yet, but somebody else was asking, right, yesterday. So similar to that, just as a DFT matrix has this ability, a 1D DFT matrix has the ability to diagonalize a circulant matrix, it turns out that a 2D DFT, right, will actually diagonalize a doubly block circulant matrix. So it's just natural. Okay, it so naturally happens that when you go from 1D to 2D, right, automatically whatever was a vehicle there that was originally a 1D DFT becomes now you have to kind of go to a 2D DFT, and that will help you actually diagonalize a matrix of this kind. Okay, and those are things that we will see later, but at this point of time, right, we just want to know that there is a nice way to relate input and output, just as in 1D LTI systems you do. There you see some structure and all. Similarly, you can extend that notion to the case when you have a 2D system, and within a 2D system also a structure exists, and then, right, such things are possible.